Uh,
Morning. Okay, good morning, everybody. Once again, back here with IoT class. So, in our last class, we are discussing on the reference IoT reference model. In that particular model, we have gone with how on a particular IoT model will be there, and according to the means IoTA and which has given by ITUU is taken into the consideration. And with that particular architecture, we have seen that how the concepts and the service capabilities and all we can build. And we have taken an example of a case study of the parking system, and that parking system how it will work. First we have studied the problem and a scenario which we have studied, and how the parking building will be there of 16 floors. So assume that it may be each floor may have two vehicles or one vehicle. It's left to the architect. Assume it's a two floors, it is there. Assume now 16 are there, then it will become a 24 vehicles. Now assume that only one vehicle can park and 16 vehicles can be parked on one by one above like that. If we are having a parking thing, then how that parking can be IoT based project means we can make it as a smart of a parking system. So that we have seen, and in a scenario they have told very clearly that one the first point will be in a gate paying gateway will be there, and once the person has paid, then he can take out his vehicle, or first before parking then he can pay, or after parking he can pay, while removing he can pay. Maybe that is a thing which is needed. For example, whenever we'll go for a mall and all, in the beginning, no one will ask you the parking charges and all. Why? Because it depends on the time. How much time you have parked. For example, starting 2 hours, it will be of 30 rupees. Later on, 3 to 5 hours, it will be of 50 rupees. More than 5 hours, means so 5 to 6 or 7 hours, it will be of 100 rupees. More than that, they will take around 200 rupees. Like that, it will be there. So in beginning, we can't take. That's a washed out thing. Then what to do? So when you are making a fully automized thing and all, so then you need two gateways. That is, one is in and one is out will be there. So while going to the in, you have to issue the token. Assume no man is there here. Automatically, a means stopper will be there. So once the person who has scanned means once his vehicle has been scanned or presses a button, automatically a token will come out. Like in many companies or many Airtel service centers or some centers you have seen. If you press a button, automatically a token will come out. So a token will come out with a vehicle number. That means imagine you must be like this. How to listen to this particular scenario means like a designer you have to listen. Assume that once the vehicle has been parked, automatically the vehicle number, everything should be taken into the consideration. How we will take a vehicle number into the consideration? Then we need one camera, like a Gaurish project. We need some camera there. Whenever a particular vehicle will comes and stands at that particular stopper area, so automatically we should capture the photo of means board photo, and we should read that particular number. Then we're reading from an image again. So that is another one important concept which will be there here. So you have to go with an Python then. So read that particular code. Once the board it has been read, then automatically you should get you may get the details from the RTO that who is the owner of this particular vehicle. So name, everything should come automatically. Once everything has been came, the green light will glow in a token box, and once he presses the button, then automatically a token will come. What are the details will be there in a token image? What are the details will be there in a token? The details will be like this. The vehicle number will be there. and then the name of the person, vehicle owner person will be there, and the time of the parking will be noted, date will be there, date and time will be there. So in status will be there. So once it is like that, a token has been given, and a UR code you can have with all this particular details, time and all. Maybe you want, you can have this particular thing. Then automatically it will generate. So they will take that, the vehicle will go, and wherever the parking slot is free, so that means that will be displayed in another screen. So there itself, as I'm a new person, I don't have an app and all. So that is the one, the screen has been displayed. So in the first floor or 16th number parking is free, or 14th number parking is free, like that it has been displayed. So the driver of that particular car will directly go to that parking place, and once he parks. Now coming to the parking place, once he parks, then automatically the parking status should become a filled up. That means in a screen, the parking status should be reduced. And like we will come to now Ashish project. In Ashish project, what actually will be there? He will have an IR sensor will be there, infrared sensor they have used. Once the vehicle comes and parks, but that particular stage, it will be filled up. So the intimation will be given, only these many parking slots will be there. Means the updation you have to do in that particular screen. Once the updation has been done in that particular screen, means coming and going of a vehicles, which is free, which is not free, like that, it will be taken into the consideration. So that will be the one particular thing which you should do at a parking area. Coming to the next thing. What is the next thing coming? While the vehicle is going out, you have to calculate the amount, and you have to take that particular amount. Assume another one gateway will keep in a exist counter. There also stopper will be there. So once the person comes and whatever a token you have given, if he scans that particular code there, then automatically it will tell so and so amount. But we already fixed it. Starting time is there, means so it will calculate. That means now here what you have to do, you must have an RFID tag which will reach the UR code. Means in the exist stage. So what are the requirements should be there? One machine should be there with the RFID tag, which will read the UR code of that particular thing. Once it reads the UR code, so and so details it has to get from our server or on a cloud. So once it will get the data, it has to calculate. Who will calculate? In our program, we will calculate in a device itself. So and so amount, everything is there. So then once the user uses a card, assume that we are having a card swapper, and once the user uses a card to swap that or scan that, well, we have to go then a gateway, and we have to take so much amount which has been generated. Once the amount has been generated, then a small printer will be there where a receipt should come out from that particular printer. This much assembling will be there. So this is assume this is one small project itself. So okay, once the bill is come out, the person will go out. So apart from this, we are having an app also in our particular project. What is the app? What the app will do? The common users, whoever are there, who knows about our parking slots and all, as you may see, parking system, which is a company which is having these parking slots. Now everyone will have an ABC parking slot app with them, and according to the location, they will see. They will select a parking slot, and they will see in that what the option should be there. That means imagine your ABC company is having a several parking slots. So then, while doing an app and all in cloud, that means several the parking slots details will be there. So according to the parking slot number, in that parking slot number, in that particular location, how many things are free. Assume I will book now. It's sorry. I will book now itself. Means while leaving a house itself, I will book. Assume parking number 4 is free. In that, the 15th slot is free. I will fix that 15th slot. I will come there. Now, these things should be reflected in your parking slot also. That is very much important. That means that once coming to the Ashish project again here, so if somebody fixes the parking slot, even though vehicle is not there, now IR register work will not be worked there. So now in two ways will be there in them. Means the project has been changed in two ways. That is, without a vehicle also, if somebody books the things, that means whenever he wants to display on a screen, or whenever he wants to give a data to an app, then he should consider the booking details also. So that is very much important. Where he will get a data from cloud again. So read the data from cloud to the device, and again, once it has been that particular slot has been booked, then automatically they should tell this particular slot has been booked, and this can become an add-up feature to them in their particular project. Once if you do, entire system will be done like this. In my knowledge, I have told almost all the scenario with taking all the functional requirements. Maybe you may feel like that we can add on this particular functional requirements and all. You can add on, not other things. So in this way, if you want to do, assume now this is a concept which you have to do the particular project. Then what I have to do? First, we'll go for a reference model. What is that reference model? The reference model itself is telling like this. First, the IoT domain model we have to create. How the IoT domain model we are going to create. The first step arises. The main concepts what we are going to use here, we are going to use in a UML notations to build a particular system. So what are the notations and all? In a OIMD, very clearly you have gone with aggregation, you have gone with the classes, how you are going to relate with one another and all. Why? Because in a parking system, as I told you, that some many different functions is there. Coming gateway is different, outgoing gateway is different, parking is different, screen is different, and then app is different. All of these are different functions, or different small projects. In that, again, you can have any subclasses also. Then how you are going to define a particular sequence diagram? What do you call for that? Anybody? What diagram it is? Active diagram or a sequence diagram? Really? OMD ಓದಿದಿರಲ್ವಾ? ಈಗ ನಾನು ಹೇಳಿರೋ ಸಿನಾರಿಯೋಗೆ ನೀವು ಮಾಡೆಲ್ ಮಾಡಿದ್ರೆ ಅದನ್ನ ಏನಂತ ಕರೀತೀರಾ? What you will call it as? Anybody? Hey, what is this? Speak up. Case study question ಇದನ್ನೇ ಕೊಡ್ತೀನಿ ನಾನು. ಸಿನಾರಿಯೋ ಚೇಂಜ್ ಮಾಡ್ಬಿಡ್ತೀನಿ ಹೇಳಿದೀನಿ, ನೀವು ಆನ್ಸರ್ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ ಎಂಟೈರ್ ಸಿನಾರಿಯೋ ಚೇಂಜ್ ಮಾಡ್ಕೊಡ್ತೀನಿ, ಅಲ್ಲಿ ಕುತ್ಕೊಂಡು ಮಾಡ್ಯೂಲ್ ಮಾಡ್ಬೇಕು ನೀವು. ಅದನ್ನ ಏನಂತೀರಾ? ಆಕ್ಟಿವ್ ಡಯಾಗ್ರಾಮ್, ಸೀಕ್ವೆನ್ಸ್ ಡಯಾಗ್ರಾಮ್? ಹೇಳಿ ಬೇಗ. If you don't talk, I don't do the lesson now. I'll stop here only. Apurva? Apurva? ಏನಂತಾರೆ ಅದನ್ನ?
Sir, activity diagram.
Correct, activity diagram?
Yes, sir.
Sahadev? Sahadev is not there. Sahadev? Suru? Shashank? See, no one is there here. Just you will switch on and you will go off from the lesson, I think so. Santosh?
Yes, sir. Activity diagram, sir.
Activity diagram, right. So you have to construct one activity diagram from that, and so you have to build within the scenario. Everyone be active. ಈಗ ನಾನು ಯಾರನ್ನು ಕರೆದಿದ್ದೇನೆ ಮಾತಾಡಿಲ್ಲ ಅವ್ರಿಗೆಲ್ಲ ಅಬ್ಸೆಂಟ್ ಆಗ್ತೀನಿ. Very clearly I'm going to tell you. So the next thing, I will share the PPT. We'll go further with this particular thing. Yeah. Coming to now. Right. Now this is the scenario which I told you, and how these things will work and all you can take into the consideration. So yesterday we have discussed all these particular things, and this is a one particular diagram, activity diagram, which you can take into the consideration. Same like this, you have to go with a case study questions also. Yeah, coming to next, information model. Now, how an information model will work? IoT domain model we have discussed, and coming to next, the information model. Now, from IoT domain model, the data will come out, and taking that data into the consideration, we should prepare some information. So how we are going to prepare information and how that information should be sent? It will be sent to a different activities there, or how the information will be different informations we have to make to send to the different activities here. Why? Because the different activities is going on in our parking slot. According to the data information knowledge wisdom pyramid, so which we had discussed in last class, which you have seen. The base will be a data, then information, then knowledge frameworks will be there. Information is defined as an enrichment of data. 100% from data we are going to construct the information with the right context. Underline the word right context, so that queries about who, what, where and when can be answered. Underline these words. This is very much important in your project, especially in IoT projects. When you are doing the IoT project, these terms should be taken in your device always. What is this? Who? What do you mean by who? Means who is the person entering? That is the first thing which you have to take into the consideration. How will you do for who? The who you will take like this, as I told you, that you will place a camera or motion capture, you will do with that particular, somebody came and stopped in a gateway, and then you will read that particular plate, means number plate, and from number plate you will go and they will fetch the details of that particular owner in RTO. Then what? So what purpose they have came here, and especially parking slot displaying in a screen. So this is so and so. I want this particular parking slot. So you can take them. Where? So in this, where which parking slot is free now, and how that parking slot should be allocated to that particular person. And when? What is the time required to entire parking system, and how you are going to do the billing? So all these particular concepts means whenever you are extracting a data, you have to generate information based on like this. The similar to the IoT domain model, the IoT information model is presented using the unified modeling language, UML diagrams. So you can go, even you can build the IoT information model also with an UML diagrams. As mentioned earlier, each class in the UML diagram contains 0 or more attributes. These attributes are typically of simple types such as integers or text strings, and are represented with red text under the name of the class. Always, whenever I want to build an entity, what entity will have usually? Entity will have an attributes and classes, means functions. So I can tell very clearly. So the main thing will comes like this, with the variables, the main any entity will be defined. The attributes is the one which will define that particular entity. Whatever value you will give to that variables, with that variable values, you are going to define one particular entity always. So either it can be in an integer type or in a text type. For example, I assume animal is a class. Animal is a class which is having the skin color, and assume skin is one variable, and joy is one particular variable. Assume tile is one particular variable. Like this, different variables will be there. When I add up a value to these variables, how is the skin? The skin golden color with the black stripes. It will be there. It belongs to the cat family, and then joy will be very strong joy. It will have with a strong teeth. So type of an food meat only it will take, means carnivorous animals. So then it's like this. So tile, a long tile will be there like that. So when I give all these characteristics, you can imagine, yes, it's a tiger. So like this, the variables itself, when you give a value, it will give some meaning to the entity. So same thing here, always the class will be defined, means the entity will be defined with the values of the attributes. Coming to the information model here, now you can see this particular model diagram here using an UML. So virtual entity, we are going to take how we are going to construct the virtual entity. That is very much important. So we are getting a value from the environment. I can say like this: I'm getting from that particular class value container will be there based on an attribute. I'm going to make it as a digitalized. That is a virtual entity I'm going to create. With this virtual entity, you can see how this is associated. Means association will be there with the service description. And from metadata, value container, what we are going to take, I will take from the outside also, rather than I will take from a metadata also. What I mean to tell you that is, I will take a board number of a car with the camera, and I will capture the particular picture of a plate. Once the plate comes, I need, means the number of a vehicle comes, I need the metadata. What for a metadata? The RTO details will be there in this particular metadata. What I need for that, if I enter the particular number, so you will get the details of that particular vehicle. So sorry, the vehicle. So that will be taken into the consideration. Based on that, attributes will be taken, what values you have to give, and one virtual entity we are going to create with that. Later on, the association will be made with this description, means service description. What service description? So and so name, how I should make alignment of that so and so name, so and so vehicle number, date, time, and the vehicle particular allotted parking slot number. So everything. Resource description will be there here again, and device description. From parking stages, we are going to take the device descriptions, and once it has been parked, we are going to generate a token based on that particular parking slot. So like this, you can build the activity diagram. Coming to the next, a more complex attribute for a specific class A is represented as a class B, which is contained in class A with an aggregation relationship between class A and class B. Association class in figure contains the information about the specific association between the virtual entity and the related service. So first I will make what a virtual entity I will create with both aggregation of this metadata and this particular sensor data. So once it has been created a virtual entity, what I will do, I will associate that with the what the sorry, what's the related services I need. So on a high level, the IoT information model maintains the necessary information about virtual entities and their properties or attributes. These properties attributes can be static or dynamic and enter into the system in various forms. So what my variables? Once whatever the values that I've given, it's fixed, it will be keep on changing. For example, I will tell you the vehicle number is static variable, means it's a static attribute, it never change. The owner of the vehicle will never change. but the time will keep on changing. The time variable will keep on changing. What is the time variable will be keep on changing, what time he has parked, so that may be keep on changing, means the end time I should take into the considerations. So that is one important, which is a dynamic which I should take into the consideration. Example, by manual data entry or reading a sensor attached to the virtual entity. Virtual entity attributes can also be digital synchronized copies of the state of an actuator as mentioned earlier. So what it actually means, sorry, based on the values of that particular thing, you can run even an actuator. Means whatever a stopper is there, when stopper should go up, once a person takes a presses a button, green light will come, presses a button, he will take a token out. Once the token he takes out, automatically a bar of stopper should go up. Now, once it goes up, the vehicle will move into the parking slot. So their actuator going up is an actuator. So when you should do this particular thing? So by updating the value of a virtual entity attribute, an action takes place in the physical world 100%. Once the printout green button pressed, sorry, green light comes and button pressed, the token comes out. The token, if you want that once you press the button, as well token will come out, automatically the stopper should go off. So this is the thing. It should be done. The IoT information model describes the virtual entities and their attributes that have one or more values annotated with the meta information or metadata. Yes, as I told, RTO details. The attribute values are updated as a result of the associated services to the virtual entity. Coming to next, function model. The function model, you know this information model. After information model, function model is there. The IoT function model aims at describing mainly the function groups. So as I told you, always once information is ready with me, what are the functions I should do? What are the functional requirements I should solve? What is this function groups? I will group the functions into functions into a group which will be in one set. For example, gateway functions, screen display function, parking function, out gateway function, like that, mobile app function, like that. I will differentiate with different groups and their interaction with the architectural reference model. While the functional view of a reference architecture describes the function components of an AFG, interfaces and interactions between the components. The functional view is typically derived from the functional models in conjunction with a high-level requirements. Now you can see this functional models. So device communication will be there here. Now assume above application will be there. Now assume this particular area here. What is this? Service organization, IoT process management, virtual entity management. It has to do how a virtual entity IoT service. So IoT service will be taken from sensors, metadata, whatever is there. Then you will build a virtual entity. After building a virtual entity, then you will go for an IoT process management. What process you have to do and all. Finally, service organization you are going to do, and application will be generated from all these particular components. So in meanwhile, the cross-layer approach will be there. From a communication to this, there is a management and a security will be applied to all the stages of this particular functional groups. Now, when you go in depth of this particular thing, this section briefly describes the most important functional groups. While the reference architectures chapter will elaborate on the composition of each functional group. Now, don't confuse. Again, you will get again the functional view. In functional view, again, we are going to discuss the same thing. But here, highlights will be there, and there, in depth, we are going to discuss. The IoT A functional model is shown in figure, which we have seen already. The application, virtual entity, IoT service, and device functional groups are generated by starting from the user how it will be generated? It will start from the user, virtual entity, and resource, and what service you need, and device classes from the IoT domain model. And from IoT domain model, using all these classes, these particular functional groups will be there. Now, what is this device functional group? The device functional group contains all the possible functionality hosted by the physical devices that are used for instrumenting the physical entities. What actually my device should do? This is the one thing. So where to place the sensors? From sensor, what data I want? After getting a sensor data, what I should do? What the function I should evaluate there? What's the process I should do there? So see here, this device functionality includes sensing, acquisition, processing, storage, and identification components, the sophistication of which depends on the device capabilities. So whatever, how a device capability will be there, based on that, you will go with the function device functionalities like this. What sensor is taking data, whether it's sensing or not, what actuator I have to run, when to run, what process my program should run, why I need a program there. You may ask me, sir, I need a program. Why? Because I have to evaluate there. Whatever data came, whether the moisture level is there, means it's more than a 500 or less than a 500, I kept a threshold. I should check it out. So for that, storing of a data. Meanwhile, I have to store a data. Where I will store a data? This is also important. After processing everything, I got a data. I should store. Sorry. I should store that in a cloud. And identification components. What identification I have to do from this particular function, doing a function? What output I should expect? What I should identify that particular component. So that things will be there. Then coming to the next thing, that is communication functional group. The communication functional group abstracts all the possible communication mechanisms used by the relevant devices in an actual system in order to transfer the information to the digital world components or other devices. See the sentence. What actually the communication group? It abstracts all the possible communication mechanisms. Either you can go with a Wi-Fi, either you can go with a LAN connection, either you can go with a GPRS, either you can go with the GPS connections. Whatever may be the connection you are using, use it by the relevant devices. According to your problem, what communication you have to use. Either your Bluetooth is enough for you, whether Zigbee is enough for you. So it depends on the problem what. In an actual system, you have to use that, and you should transfer the information to the digital components, to the cloud or to the server. I should transfer that particular thing. Otherwise, I should transfer that to the actuator. I should run the actuator. It depends. It depends on your problem of a project. Then IoT service functional group. What is this IoT service functional group? The IoT service functional group corresponds mainly to the service. What the service I should get from this IoT project? So that is the one question arises. See, the IoT service functional group corresponds mainly to the service class from the IoT domain model. What your IoT domain model is giving, either what service it should give to generate or to solve this particular functions, and contains a single IoT service exposed by the resources hosted on devices. What are the sensors, what actuators you have to give? From that, it is going to generate some services, or in a network. It will keep in a network, or you can communicate with that. Example, processing or storage of the resources. Coming to next, virtual entity functional group. This is important here. The virtual entity functional group corresponds to the virtual entity class in the IoT domain model. I'm getting a data from a sensor, I'm getting a data from the actuator. Assume I should run an actuator, my device is there. For that, I should create some virtual entity to take that particular values. I need some variables, I need some class there, I have to do some functions there. The virtual entity functional group corresponds to the virtual entity class in the IoT domain model and contains the necessary functionalities to manage associations between virtual entities with themselves as well as association between virtual entities and related IoT services. So once I created this virtual entities I can relate, associate to which service, what service I want. I will take the values in a variables. That variables values where I can use, in which class I can use, what service I can use. So that is association we have to make in that particular IoT information model what you are seeing. Associations between virtual entities can be static or dynamic depending on the mobility of the physical entities related to the corresponding virtual entities. Assume based on the mobility, this is not superior. That means assume my device is moving. It's a mobility device. My project is like that. It's moving from one place to another place. For example, monitoring of my patient. You take that particular project. In that particular project, patient can move from wherever. Means from one place to another place, he will be keep on moving. How you are going to monitor him? My device will also move with him. So then the association between the virtual entities, either it's a static or dynamic, first you have to define depending on the mobilities. So how mobility of the physical entities is moving on that. Then IoT service organization functional group. The purpose of the IoT service organization functional group is to host all the functional components that supports the composition and orchestration of the IoT and virtual entity services. That means whatever my IoT domain is there, whatever my virtual entity services is there, what is this organizational functional groups? This will organize all the functional groups according to the way. First this function, next to this function, next to this function it has to do. So then virtual entity sets should be related to this, associated to this service. After this service, next service should come. The sequence of servicing is very much important here. Why? Because the first, maybe one service output will become an input to the another service. So that you have to keep in your mind while doing a project. So moreover, this functional groups acts as a service hub between several functional groups such as the IoT process management functional group. That I told you. So what I told you that maybe one service, it will be in a hub. So one service, if it works, then another service will work. Like that, so it will be a hub of one particular function. For example, IoT process management is a hub. So where entire IoT process of our project will be done and it will be a hub for all other functions. For example, service requests from the application or the IoT process management are directed to the resources implementing the necessary services. Based on our goal or an application output, the IoT process management, it will be linked to the resources always to give the services. Resources are nothing but our device, our gateways, our network, our communication, our sensors. Then IoT process management functional group. What is this? The IoT process management functional group is a collection of functionalities that allow smooth integration of IoT related services. I will add up this service, I will add up this service, and I will add up the other service to my particular project, and my project will be in a different services. For example, entering a gateway of my parking is one service, allotting a parking slot is one service, and going out gateway is one service, screen display is one service. For all these particular services, it should be managed. The IoT process management functional group, what it will do, it will link all this. It's an hub. In center hub, it will have an hands with all these particular groups. The IoT process management functional group is a collection of functionalities that allow smooth integration of IoT related services. What are that? IoT services, virtual entity services, composite services. With the entire enterprise business process will be managed from this particular IoT process management. Imagine your parking slot doesn't have a human being interaction. Just for a maintenance purpose, you need a persons. Next, management functional group. The management functional group includes the necessary functions for enabling the fault and performance monitoring of the system, configuring or enabling the system to be flexible to changing the user demands, and accounting for enable subsequent billing for the usage of the system. So this is the management thing. What it will mainly focus on a fault and performance monitoring. What else you need? Either no one can do 100% project. Keep in your mind always. I did a project. I got 100% output. No, it's wrong. It's wrong. No one in the world can do that. I can say, even in the companies also. I mean, companies will make a app. They maybe some services they can't add up. Later on, after the customer is using, getting a feedback from the customers and getting a requirements from the customers, updating of a project you have to do always. That means what is updating here? Updating means adding up of the features, adding up of some services to your project, and according to the human means customer requirements, based on their feedback, you will keep on changing your projects to get an optimum performance. So like that, always the projects will be there. That's why I will tell you, whenever you are giving a demo of your project and all, don't think that my project not like this in a real world 100% output it's giving. No, it's not like that. We are making a prototype just in a place. And our idea is very much important. First, the first point is that is very much important. Whenever you are doing a project, first analyze your idea. Either this idea is there already, either the innovation is there already. Yes, maybe your idea can be there with other persons also, and they may have the same idea. Okay, not to worry about that. What is this idea? Learn that first. That's a literature survey. Learn that. Okay, I saw some 10 apps, or I saw some 10 projects of a similar type. For example, a smart cradle. So all this is there. What is my add-on to this particular project? So if they have made a ABC, I added a DE, then mine become a new innovation. 100%, mine is a new innovation. Why? Because I can tell all the projects what are there. They are having ABC only characteristics. I added a D&D characteristics of that particular project is not there. So we can define like that. So that's way, once you have did a project, even though if you have implemented the project, then the performance monitoring of that particular project is very much important. So based on user demands, accountable and billing using of that particular system, how to change and all. So still what to add up like that. Then security functional group. The security functional group contains the functional components that ensure the secure operation of the system as well as the management of privacy. This is very much important. The security, why? Because no human interaction will be there. I trust and I'm telling on that. Then what about the security operations on your device? Or the interior project. So that you should define. The security functional group contains the components for authentication of users, means applications or human beings, authorization of access to the services by users, whether he is authorized to this or not, based on the API case or based on his given a credentials, you can decide what service you should give to him. Secure communication means what is a secure communication? I will use some encryption algorithms for communicating from one device to the another device between entities of the system such as devices, services, applications. And last but not least, assurance of privacy of sensitive information relating to human resources. This is damn very much important. So the person should have a confidence to use our particular project, or our customer should have a confidence. If customer doesn't have a confidence, if I give my credentials and all to this particular app or this particular project, if something happens for that, what is the security? This is a very important thing. So privacy of sensitive information relating to the human resources is very much important. Then the next one is a applicational function group. The application function group is just a placeholder that represents all the needed logic for creating an IoT application. It's the final what our users should get. So that from our project, the applications typically contain the custom logic tailored to the specific domain, such as a smart grid. Next, modular IoT functions. So it is important to note that all the functional groups are needed for a complete actual IoT system. The functional model as well as the functional view of the reference architecture contains a complete map of the potential functionalities for a system. So that will come under the modular of the IoT functions. How I should model which function, which will come next. How function groups I should relate with each other. So that will come in that particular thing. Uh, yeah, next we'll go for a functional view. Next class. Let's stop here. Any doubts? Any doubts? ಅವಾಗಲೇ 33 ಇದ್ದಿದ್ದು ಈಗ 44 ಆಗಿದೆ. What do you mean by this? At the end stage, someone will come and join. I'll allow that. Never I will allow that. And I know who are all the participants. What is this? When you write exam, no, exam will be there 100%. So you have to write only this time. Last semester you are lucky you have did like that, but this time compulsorily you have to write. Well, there are questions, then you can understand what's the problem with that. Aditya.
Sir.
Ajay.
Yes, sir.
Ahmed.
Yes, sir.
Antima.
Present, sir.
Apurva.
Present, sir.
Ashwini.
Yes, sir.
Bindu. Divyesh. Gaurish.
Yes, sir.
Gautami.
Present, sir.
Gunashekar.
Present, sir.
Harini.
Present, sir.
Surya Prakash.
Present, sir.
Naina.
Present, sir.
Nazma.
Present, sir.
Nidhi. Pradeep.
Sir.
Preeti.
Present, sir.
Rajesh.
Present, sir.
Sahadev.
Sir, his mic is not working.
Saket. Santosh.
Present, sir.
Seema.
Yes, sir.
Sinchana.
Present, sir.
Shruti.
Present, sir.
ಶಶಾಂಕ್.
Present, sir.
ಅವಾಗ ಯಾಕೋ ಮಾತಾಡ್ಲಿಲ್ಲ.
Sir, mic on ಆಗಿಲ್ಲ ಅವರ.
ಸುಳ್ಳು ಹೇಳೋದು ಕಲ್ತಿದ್ದೀರ ಎಲ್ಲ ನೀವು. ವರ್ಷ.
Present, sir.
ಯಶಸ್ವಿನಿ.
Present, sir.
ಅಮೃತ.
Present, sir.
ಅನುಷಾ.
Present.
ಬಂದೇಳ ಅನುಷಾ. ಅಪೂರ್ವಕ್ಕೆ.
Present, sir.
ಅಪೂರ್ವಕ್ಕೆ.
Present, sir.
ಸಾಯಿ ಸಿದ್ಧಾರ್ಥ್.
Yes, sir.
ಚೇತನ.
Present, sir.
Yes, sir.
ಕಾವ್ಯ. Kavya, Kavya Y, Madhusri, 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 Manish,
Present, sir.
Sarfaraj,
Present, sir.
Murugesha,
Present, sir.
Mani,
Present, sir.
Paresh, Pooja,
Present, sir.
Prashant, Pratibha,
Present, sir.
Pratik, Sadhana,
Present, sir.
Shashank, Shashank, Shraddha, Shraddha, Sridhar,
Present, sir.
Tanoj,
Present, sir.
Tejaswini,
Present, sir.
Ani,
Present, sir.
Ashish, Ashish, Vidya,
Present, sir.
Vishal, Vishal.
Present, sir.
I'll stop recording.
So, Nidhi